Hi, this is Prashant Bharadwaj. Today's lesson is going to be about the trial and error technique for aggregate planning using Excel spreadsheets. If you recall, in a previous module, I had said that there are two major techniques for solving aggregate planning problems. One is the classic linear programming. Linear programming provides the optimal solution, which is the best solution in terms of minimizing cost. However, linear programming is not used as much as trial and error technique because most people are familiar with Excel. Whereas if you use the linear programming technique, you need to have expertise in LP. And the kind of expertise available is not very common. So most people look at trial and error, and I'm going to talk about the steps involved in that. If you look at this, there are 8 steps according to me. The first step is you have to determine what the demand is. This can come from a forecast, or it may be firm assured orders. So if you look at our example, what I have done here is I have used an assignment, a real example, so that you can relate to each of these steps. So the first step you see is identifying what the demand is for a 6-month horizon. In reality, the horizon may be 6 months, 12 months, or it can go all the way up to 24 months. So in this example, we are going from January to June. And as you can see, the range of the demand is from 1200 to 3600. That's a big range. So you as an operations manager has to figure out what your production is going to be, what your capacity is going to be, what your inventory is going to be. Second step is to determine the capacities. When I say capacity, you got to know how many workers you have on your payroll. How much time do they typically work? It may be 30 hours in some companies, it may be 35, it may be 40 in some other companies. What is your capacity in overtime? In some places, you have a capacity on overtime. You cannot use that indiscriminately. So there may be a constraint which says no more than 10 hours of overtime in a week or 25 hours in a month. Another capacity may be subcontracting. You may be able to subcontract, but your subcontractor also may have a particular capacity constraint. You need to know all this data. You may need to know what is the maximum you can produce, and in some cases there may be a minimum because we have talked about economies of scale. You cannot produce a small quantity economically in some cases. So in this example, we have a workforce of 30 workers. There are 20 approximate work days, excluding the Saturdays and Sundays. In some problems, you may be actually given the exact days in each month. So January may have 22 days, February may have 18 days, March may have 22, and so on. But to make it simple here, I have just said there are 20 average work days per month. One more thing that I have provided is labor hours per unit. So you need 2 hours per worker to produce this product. That is a shirt in this case. So that is step number 3. Step number 3 was determine production and service data. How many hours per unit? So we know in this case you need 2 hours per unit. In other words, in an 8-hour day, a single employee can produce 4 shirts. So in a typical month where there are 20 days, one can produce 80 shirts. So if you want to look at the capacity of this workforce, it is 2,400 per month. Let me repeat how I got the 2,400. You need 2 hours per worker to produce 1 shirt. In an 8-hour day, one can produce 4 shirts. So in a typical month, a single employee can produce 4 times 20 work days, 80 shirts, and with 30 workers, you can produce 2,400. But now look at this. What is my demand? My demand is varying from 2,400, drops down to 1,200 in February, increases to 2,800, and peaks at 3,600, goes down to 3,200, and then again goes back to 3,600. I'm planning for this. My capacity is 2,400 units per month. Going back to step number 4, you have to estimate the entire set of cost data. Looking at our data here, if I produce more than 2,400 in the first month, how do I do that? One way is to schedule overtime. Do I need to do that? The second question. My demand is only 2,400. I can produce 2,400 in regular time. So why do I need to produce more? Maybe you don't need to. If you look at the future, you have 1,200 in February. I don't even need 2,400, my regular production there. But should I produce less? Maybe, maybe not. Look further. Your demand increases to 28, 36, 32, so on. So it is a good idea to continue producing 2,400. It may be even better to produce more than 2,400 using overtime in January, February, so that you will be ready for the higher demand in March and April. That is why I said this method is called trial and error. If it was linear programming, all I had to do was feed all this data, the demand data and the cost data, into the linear program, and it is a set of algebraic equations which are solved, and you will get the optimal solution. What is the exact production in Jan, Feb, March, April, May, and June? What should be the inventory? What should be the overtime? What should be the subcontracting? All of these are provided to you in the solution. But as I said, linear programming is not easy. Very few people have the expertise in industry. That is why it is not as popular. Whereas the method that we are discussing now, the trial and error, using Excel spreadsheeting, everybody is familiar. Anybody can do this without assistance from experts in linear programs. Going back here, cost data is holding costs. That is, if you produce more than what you need in a particular month, you keep that in inventory. You hold that in inventory. The cost is $1.50 per shirt per month. So if I produce something in January, and if I don't use it until April, I'm keeping that in inventory for 3 months, Jan, Feb, and March. So I'll be incurring 3 times $1.50 per shirt. What if I have a shortage? As we have discussed earlier, having shortage in most industries is worse than carrying inventory, because, especially because if you're producing something which is a commodity, which can be bought in some other place. People are not willing to wait. So shortage or back orders are more detrimental than holding. Holding also has a problem, as we have discussed, because you're incurring inventory carrying cost. In this example, it costs twice more if you incur a shortage than if you incur holding. So it is $3. In other words, if I fall short in March and I meet the demand in April, it'll cost me $3. If I fall short in March, if I meet the demand in a back order in May, it's going to cost me $6 per shirt because the delay is 2 months. Another cost, subcontracting cost, is $25 per shirt. If you want to just subcontract the product and not produce it in-house in regular or overtime, it'll cost me $25 per shirt. Next, you can hire people. If the demand goes up, you can hire. We have discussed this in the different strategies. You can lay off people in some instances without major problems to the organization. But there is a cost involved, and we have discussed this at length. If you hire somebody, you got to train them, and there's a learning curve, so on. So there is a $200 that this company has estimated per worker to hire. If you lay off, similar issues. You got to, at some point or another, you got to hire people. So all the costs involved in hiring are embedded in the layoff, in addition to loss of morale, if you are a company which is laying off people when the demand goes down. So typically, the cost to lay off is higher than the hiring cost. In this example, it is $300 per worker. And the two basic costs, which is regular time, you are paying these employees $8 per hour. And on overtime, you are paying $12 per hour, which is typical time and a half. Now with this data, we have identified all the first four steps. We know the demand, we know the capacities, we know the production and service data, that is how much you can produce. We have the entire cost data here. Now the fifth step before we can actually solve the problem is identify appropriate company or departmental policies. Are there any policies in the organization that you have to carry a minimum safety stock of 10% over forecast demand? So in that case, if the forecast is 2,400, you as an operations manager will plan for 2,400 plus 10% of 2,400, which is going to be 2,640. Or you may have to maintain a minimum workforce level. So in this case, you have 30 people. So you may have to hire and lay off people in your plan, but the operations manager is told that you cannot go below 25 workers. So you have to stick to that company policy. It may say no back orders at all. So you have no option of having shortages. So in this case, you have holding, which is you produce more or exactly what is required. So these are all different kinds of policies which the operations manager cannot deviate from. These policies are either provided by the financial manager or a human resource manager with whom the operations manager is going to work with. Now, we have to develop alternate plans. That is the whole idea of trial and error. So what are some of the alternate plans? Let us brainstorm. What exactly would you do in this situation? Let me give you some examples of what you could do, and then I would expect you to solve this problem using trial and error. If you're good in Excel, you can do hundreds of different options. In practice, most people would look at 10, 15 different options and pick the best or the most ideal for them. Sometimes the least cost solution may not be the best solution practically. So what I always tell my consulting clients is look at all the different options, and the quantitative steps are always just the first step in making the final decision. You have to use some qualitative judgment before you implement a solution. Sometimes the third least expensive solution may be the best solution. The least and the second least options may not be practical. So let us look at some options now for this particular problem, where you have 6 months of demand varying from 1,200 to 3,600. Let us look at the extreme example. The extreme example is I'm going to have as many workers as we need in each month. So this is the classic hire and layoff policy. So if you look at this, how many workers do I need in January? I need 30 workers. If you recall, what can I produce with 30 workers? I can produce 30 times 20 days, which is 600, times 4 per day, 2,400. Each employee can produce 80 units per month. So if I go to February, how many workers do I need? exactly half the number of employees. So I can only have 15 employees in Feb and produce exactly 1200. When I come back here to March, I have to hire more employees. How many employees do I need? 35 employees, because I need to produce 2800. I need to hire employees from Feb to March. Same thing. When you come here, I need to have more number of employees. I need to have 45 employees. You come to May, you have to lay off employees. You need only 40. Again, hire more. Obviously, this is a strategy that you can consider. But is this something that you really want to do in this case? It is up to you. That is what I mean by a qualitative judgmental decision. You can go through the math and see what will be the cost. If I go from Jan to Feb, Feb to March, I'll be hiring and laying off people. I figure out how many people I need to hire, how many people I need to lay off. And I know what the cost is to hire and lay off people. And I need to figure that out. Is there any inventory involved in this strategy? None, because you are producing exactly what is required. You are hiring people and laying off people so that your capacity matches the demand. Is there any subcontracting involved? None. Is there any shortage? No. So the only cost here is hiring and laying off, and of course the regular time production cost, because for every unit you produce you need people and how much time they're working, and it is $8 per hour. So what I just explained to you is a strategy. You can try that. Is it feasible? Maybe. Is it ideal? Maybe not. Now let me take you through another option, which is a more popular option in practice, which is a level strategy, which we have discussed. What I just described now was a chase strategy. You're chasing the demand, which is not as popular, or at least as popular with the workforce. Now let us look at the level strategy using this Excel spreadsheet. In the level strategy, if you recall, you are producing the same quantity every month, every time period. This is what a worker would like, given a choice. So in this example, what I have done is I have translated the data first into the Excel spreadsheet. So it's a level strategy, produce same quantity each month during regular time, and utilize overtime or subcontracting if necessary. So what is the regular production capacity? We have gone through this a couple of times now. It is 4 per worker in an 8-hour day. So it is 4 times 20 work days times 30 workers, 2,400 units per month. Or in other words, each worker can produce 80 units per month. Here you see the forecast repeated from our data. January to June, we have the demand data varying from 1,200 to 3,600. But what is the average and the total? It is 16,800, and the average is 2,800. Okay? So if I produce 2,800 per month, then it will be meeting the demand. Go back. What is my capacity in regular time? 2,400. So what am I going to do? Produce 2,400 every month in regular time. So this is the forecast. Now I have to look at output. I have 3 ways of producing this. 3 ways of obtaining the output: regular time, overtime, and subcontract. So in my strategy here, I'm using only regular time and overtime as necessary, but absolutely no subcontracting. So I need to produce 2,800 per month. But if I'm smart, I don't want to produce 2,800 in the first few months. Why? My demand is only 2,400, 1,200, and it jumps to 2,800 in March. But I would have produced a lot more in Feb, so I don't need to produce 2,800. But come April, my demand is in this range, 32 to 3600. That is when I need that extra overtime capacity. So what did I do? I produced regular time 24, 24 all the way, and then I produced 800, 800, 800 extra in April, May, and June. In another trial and error, you can just spread this 2400 across the 6 months, which is 400 every month. If you think that your employees are not going to be able to produce 800 only in these 3 months, if HR folks tell you that this is too much overtime in 3 months, you can spread that around over 6 months. But in this example, in this illustration, I have said that there is no overtime in the first 3 months, and April to June I'm using 800. By the way, in the assignment, I have given you the flexibility, the freedom to do whatever you want, but I have asked you to explain to me your strategy and your rationale. You have to be very clear why you picked this 800 every month in the last 3 months, or if you picked 400 every month in that particular problem, you have to tell me why you did that. So now, if you look at the total output, it is 2400, 2400, 3200 with regular time plus overtime, same in these 3 months. And there was no subcontracting in my strategy. In your case, if you use subcontracting, you have to put that number and then use that in your calculation. So now the next step is every month I'm checking at output minus forecast. So 2400 is my total output minus the forecast. Okay, so it is 0. I produced exactly what I needed. Feb, I produced 1200 more. March, I produced 400 less because I produced 2400. My demand was 2800. And same thing in April. In May, I produced exactly what is required. And in June, I produced 3200, but my forecast was 3600. So I have 400 less. Now, let us calculate the actual inventory. Remember, my strategy is complete now. This is a very simple strategy. All I'm doing is producing in regular time everything that I can, which is 2400, and in 3 months, I produced overtime of 800. Now, I want to know how much this particular strategy would cost me compared to a chase strategy or some other strategy. So what are the costs involved here? The costs are definitely the regular time production, overtime production, and in some cases I had inventory, and in some cases I might have some shortage. Let us figure that out. I have 3 different rows here. What is the beginning inventory? What is the ending inventory? And what is the average inventory? In some companies, they just use the ending inventory to calculate the holding cost. But in some companies, they use average. That is, what was the beginning, what was the ending, what is the average of the two. They use that to calculate the holding cost. In our example, let us do that because that is more common and a little more complex. So if you understand how that is done, then in some cases, if you just use the ending, you know how to do that. So you have the beginning inventory. We'll assume we started at 0. And look at the ending inventory here. It is 0.2 because you produced exactly what was required. So your average obviously is 0 and there's no backlog. Now the ending inventory of Jan is the beginning inventory in Feb. What is the ending inventory in Feb? It is 1200. Okay. How did I get 1200? I produced 2400. I had nothing to carry from the previous month, and I used up 1200, so I'm ending with 1200. The average of 0 and 1200 is 600. Going into March, I'm carrying the same 1200 that I did from February end. I produced 2400. That makes it 2400 plus 1200 is 3600. minus my demand or forecast of 2,800 is my 800. That is my ending inventory. Let me repeat. I carried 1,200 from February, add that to the 2,400 that I produced in March, which is 3,600, minus 2,800 of forecast, which is my 800. The average of 1,200 and 800 is my 1,000. One more month, just to be sure. The ending inventory of March is carried to the beginning of April, that is that 800. Add that to the 3,200 that you produced in regular and overtime, that is 3,200 plus 800 is 4,000, minus the 3,600 that you would sell or use, which is my 400. That is my ending inventory. The average of 800 and 400 is 600. The next 2 months should be obvious to you. Using the same rationale, you can calculate the beginning and ending. By the way, I did not do it by hand. I used formulae to figure out. So depending upon your Excel expertise, you can program this in such a way that you can make small changes and automatically see the results of that. I will not be able to spend too much time on teaching you Excel here. So if you're not very good in Excel, you can make some of the calculations manually. In this example, there is no backlog, so 0 throughout. Hope everything is clear now. What the average inventory is each month, what is the regular time production, what is the overtime production. Now is the time to calculate the cost. The costs here, you have regular time, overtime, no subcontracting in this case, so that is why it is 0. No hiring, no layoff, and no back orders. I have set this up in such a way that if I change my strategy, automatically these numbers or these cells will be populated. Now let us calculate the regular time and overtime cost. How did we get this 19,200? Very simple. You are producing 2,400 units, and each of these units require 2 hours. So 2,400 times 2 times the regular time cost. How do we calculate the regular time? The regular time cost is $8 per hour. So you have 80 workers who are working 8 hours per day at $8 per hour. So if you do the math, you will get this number 19,200. Is that going to be different for each of these months? No. So this number is going to be the same for every month because you're producing 2,400 every month. And this is my total regular time cost. Similarly, overtime, there is no overtime in these 3 months, whereas here you're producing 800 units at the rate of $12 per hour of overtime. So if you do the math, that is 9,600. The inventory holding cost is $1.50 per unit per month. Where do I get the 900 from? All I'm going to look at is 600, 1,000, 600, 400, and 200. These are my average inventories at the end of each month. I'm just multiplying 600 by $1.50, 1,000 by $1.50, and that is how I got my holding cost. And that is my total holding cost. And 148,200 is my total cost for this particular strategy that I've used. So it is close to $150,000. Even if this is the least expensive of all the trials that you went through, like I said, you can use subcontracting, you can spread out the overtime, you can hire more people, you can lay off people, a lot of different strategies you can use. At the end of the day, after you run half a dozen or a dozen strategies, and even if you find out this 148,200 is the least of all the strategies that you have tried, I am not recommending that you go with this 148,000 unless you have used the expertise within the organization to determine that this is the ideal strategy in practice. So every 6 months, every 12 months, your strategy may differ. So this gives you an idea. I have kept this problem very simple without complicating anything with company or departmental policies, and hopefully this should be clear enough to solve the problem that I have assigned to you. And finally, if I was using linear programming, I don't have to do any of these. I can feed this data to the linear program and it will give you the final solution, which may be a combination of regular time, overtime, subcontracting, hiring, laying off, and so on. Thank you.